Today we're going to continue talking about technology and map making. And if you remember back to Monday's lecture, I made the point about finding the right tool for the job. Depending on what job you're going to do, you're going to need different tools. So you look at these are all used for different things. Now there's some overlap, sure, but some of these are not going to work in other jobs. If I need to tighten a certain bolt, then I'm going to have to use a crescent wrench. But this crescent wrench is not really good for hammering in nails, and it doesn't cut wire, and it's not going to tell you if something's level. So you find the right tool for the right job. Now we've looked at some different types of maps. Here we have a map of the Grand Canyon, and this is actually a relief map. So you can see the shadows and the shading, how it plays out, and you have the sun, the source of light kind of coming from here, and you can see the shadows that it makes, and so this gives you a good idea of what it looks like. And then here's actually a piece of a topographic map of the Grand Canyon. And so you have all the different contour lines, you have your different elevations, and you can see some of the different features here that are made in the topographic map. But what if you need different information? I mean, yes, there's a lot of information in these different types of maps, but it's not going to be good for every single type of job that you would need a map. So we come to another type known as a geologic map. Geologic map is a map that shows the surface geology of the area being mapped. So that's one of your vocabulary words. So you might ask then, what is geology? Just like we talked about what is topography, what is geology? Well, geology comes again from a couple different Greek words. The word ge means earth, so that's where we get our geo. Remember, like geography. The ge is the Greek word, means earth, and then logia or logos. The idea is discourse or study of. So biology, the study of life. Geology has to do with the study of Earth, but more specifically with the study of rocks and rock formations. So a geologic map is going to show rock types, it's going to show their ages, it's going to show locations of things like faults. And so here I have an example of a geologic map of the Grand Canyon. So you see here, yeah, you can see some of the topography, but now we've got all these vivid colors. So what in the world is this showing us? How can we discern which types of rocks or what type of formations this is showing us? Now, the idea of the geologic map actually goes way back, way back. Some of the actually, the earliest recorded geologic map is on what's called the Turin Papyrus. I got a few different examples of it here. If you look here, look closely. This is a map, and so we see that, you know, you can make out some of the geologic features and things like that. But this actually dates back to 1150 BCE. And this comes from Egypt, and it shows the locations of building stone, gold deposits, things like that. And it describes this 15-kilometer stretch of a place called Wadi Hammamat, and it shows where some of these places come together. But they got the importance of knowing where they could find certain things. They built with stone. Gold was extremely valuable, and so they decided, we're going to make a map that's going to show us where all of these things are. And thousands of years later, we think that's a good idea. We also need to know where these things are. Now, the first geological map of the U.S. was produced in 1809 by William McClure. Now, he crossed the Appalachian Mountains, the Allegheny Mountains, sorry, some 50 times. Just went back and forth and surveyed and studied the different classes of rocks and things like that, and then made his map to let people know what type of terrain, what type of rocks they could expect. Is it good for building? So all of this information. And then here we have an older geologic map of all of Europe. So again, if you can zoom in, you can see the legend here, and it'll tell you a lot of the different symbols and things like that. Now today, geologic maps are, you're most likely not going to use a lot of them or even see a lot of them unless you go into a field that that requires you to have an understanding of geology. If you do any kind of drilling, working in any type of some of the different energy fields like oil, things like that, they want to understand the geography. So there's not a lot of geological maps of the United States. Sure, you can find them, but they don't really make a lot of them. Now, some states, in particular Georgia, Kentucky is another one, puts out their geological maps and spends a lot of time understanding what the geologic makeup of the state is. So you can take a look and see the explanation here in the legend of all the different rock formations and types of stone and sediment that you can find throughout these areas. Now, the maps themselves, they're a lot more complex than a topographic map. Now, if you remember yesterday, I showed you the legends of some topographic map and some of the symbols. Now, they're nothing compared to the geological maps because here they're showing all these different symbols for how the angles of the rock formations, and it gets into some very complex geometry. In fact, they use very specific compasses in order to find the geometry in the faults and folds of the strata or layers of rock, and so they will mark these on the map. And in addition to that, they're also going to show where there's certain types of quarries, certain types of mines, and they might even show some topographic symbols. So you can see there's some similarities, but they're not going to be the same. Now, if you want to study one of these, you've got to understand all of the symbols. See, these are just fault symbols here. Different types of faults and the way that they move. This is lineation symbols. This is bedding symbols. And so it gets into some really complex geology. Now, another important feature of geologic maps is the use of color. The color and the symbols, along with the age of the rock formations, these colors aren't going to tell you what colors the actual rocks are, but for the map purposes, this is how they note them. So if you look at some of the different maps, you'll see all these different colors, and it tells you what types of stone, what types of formation you're going to see. This one here lets you know the age as well. Another thing that you can use, another type of geologic map, has to do with a cross section. So sometimes scientists need to know what the rocks are like underground as well as the surface. So how in the world are we going to know what it looks like? Because sometimes for us it just looks flat, or you might just see a hill or a certain type of geologic or geographic formation, but what does the rock look like underneath? So remember, our map view is looking down. Here we have a cross section, and this is a profile view. So remember, profile, you're looking from the side at the object. So a cross section is a profile view that shows a vertical slice through the rocks below the surface. Now, how they figure this out, they can gather information by drilling for samples. They study earthquake waves. They can look at cliffs. Now, I'm going to show you here an example of a cross section. So here at the top you have your geologic map, and you have your different types of stones color coded. But here we can see the cross section, what it really looks like. When you're looking just at this map, you can't see this kind of fold and dip in the rock layers and the strata. So scientists will take some core samples, study different things, maybe look at the sides of cliffs to see these kind of formations underground. And then they'll come up with a cross section. Now think back to our map of the Grand Canyon. Here we have our geologic map, and we have our relief map and our topographic map. Now let's look at a cross section of the Grand Canyon. So you can see here, this gives us on the left side here, some information about the dates of the stones. And now it's going to be rough. It's not going to be exact, but you're talking in, so it says approximate age in millions of years. So you have a cross section of the side of the Grand Canyon, and it gives you all the different types of stones and information about them, as well as the geologic map next to it. So you can see how this would be an extremely useful map if you were going to do any type of drilling or digging in that area, or even if paleontologists might want to look and if they find a fossil on the side of the Grand Canyon and they can see what strata, which layer it's in, to give them an idea of what time period this creature that they're looking at comes from. So that's the geologic map. Obviously, there's a lot more information on it if you want to do some study on your own, but there are a lot of really complex symbols and things that they use in it, and we'll talk a little bit about it in our interactive session during our blocks.